Hello everyone, welcome to section 3, the application and benefit of the solar charge maximizing controller system. This is a lecture 9. This lecture we stay focused on the off-grid or hybrid system application. You say, some of them may ask, you say, the solar charge maximizing controller system can have very high capacity of this DC current, but what is it used for? So we list many applications here in different voltage systems in different countries and give you a touch, an idea what this system can be used for. The whole lecture here, we stay focused on the system without net meter. So in this system, you do not need to apply to the utility company to have the solar array tie into the grid. You could still have hydrometer, but you don't need to apply for the grid tie permit. Because we know that grid tie permit is not easy because the utility company would have to make sure the grid can support lots of this solar energy dump into the grid when the sun comes out with the maximum solar conditions. They would have to make sure the grid is upgraded to be able to carry the load in, because they still have to transfer that solar load from point A to point B to the customer. So, and this whole system, lecture here, lecture 9, we stay focused on the system without grid tie approval. And in this system, you can still have two options, two different scenarios. One is that completely off-grid. You don't have no hydro meter at all because there was no grid available. Say you live in a remote location, in a cabin, on the boat, cottage, no power supply to it, that will be completely off-grid. So this is the section, this is the lecture we stay focused. The first would be like this one here, 220 volt system VAC is 50 hertz system, single phase. A lot of residential houses would have this kind of the power supply to the house, and it comes to the regular meter. Regular meter, you take just single phase, 1 9 voltage, 1 neutral, only 2 9 coming into the property, and you have maybe other load directly connected to the supply line of the meter may have other load, but you say, okay, I have a specific load run a lot of time during the day, AC load I run them, use them a lot during the day, say home office. So you have a lot of AC load during the day. It will be very good for this system to set up, because the reason is that solar charge maximizing controller, so of course this is a common negative system. This battery bank will not need to be huge, because majority of the current will go directly to power the DC load, which is inverter, off-grid solar inverter in this case, to power that AC load directly without charging the battery. So when the sun comes out, and then we got 120 amps coming into this line, we may get 80 amps coming into the solar charge, the MPPT solar charge controller. You can have maximum 200 amps capacity, or times 24 system, or times 48 system. That's quite a lot, this power, 5 kilowatt power system on this 10 kilowatt power system. And the system will rely on automatic transfer switch. This automatic transfer switch, Morse automatic transfer switch, is quite reliable. We test this transfer switch for years. They work like transfer the power in 10 milliseconds, depends on the grid to solar or solar to grid, maximum 35 seconds. In either case, you can have the load here include a personal computer. It will not offset the personal computer without even UPS connected to the personal computer. So lots of these appliances say the lighting fixture connected, you don't realize there's a switch change. So what is the switch change point? We mentioned the voltage control, the system voltage control. We want to maintain 20% to 80% the range of the charge. By 24 volt system, we control the voltage between 25.5 and 26.5.6. We want this automatic transfer switch to cut in. So they have the battery power, this communication line, like a small, this voltage sensitive line goes into this automatic transfer switch. You set the voltage. It's an option for you to, it's like you can adjust the voltage in a very wide range. You adjust that for 26.5, 26.8 to cut in. And when it's cut in, the switch will go to the PV system, and then they will draw the power from the battery bank or from the solar charge maximizing controller system directly to power the off-grid inverter. This inverter has to match the load, match the grid power. So it will suddenly change to the solar power system, span the load, and when the system voltage drop, you size it properly. When the system voltage drop to 20% mark, like you got a 60% this range to play with. Once it dropped down to 20% mark, which is a 25.6 volt, and then you set them to cut out, and this switch will fall back to the grid. So grid can still power the AC load what you have, but whenever the solar condition allow, whenever the DC current is available from the system, we will be able to charge a 9PO4 battery. You call it 9PO4 battery too. It's a lithium iron phosphate battery, LFP battery, or you call it. When the voltage build up, and this automatic transfer switch will sense the voltage, and it will cut in again, disconnect power from the grid, and then use the power from the AC system. You only need to make sure this capacity sized properly to prevent that short cycling from happening. We're going to do another lecture explain how to size the system properly to prevent the short cycling from happening, because that's likely is going to happen because you have 60% of the capacity range to play with. And you only need to make sure that solar array capacity and the battery bank charging capacity, they are going to have some kind of match. We explain them in different lecture, but this is how this off-grid system can be set up. Without grid power here, we call them off-grid, completely off. With the grid power, but you'll not be able to do any grid time, you call them a hybrid system. That's why we say off-grid system or hybrid system. If you have a hybrid system, means the load can be run by the grid power, the load can be run by the PV system. So if it's completely off-grid, then you probably would have some kind of generator there. Instead, you have a grid power here. You may have a gas generator here, just in case you do not have this kicks in. But the setup would be different because you need a time to do the transfer. The transfer switch you are using could be different. But this is the system with the grid power and PV system. We call them a hybrid photovoltaic system to power the load. And this system, the benefit would be to save the power, minimize the power consumption, minimize the power draw from the grid, because normally daytime the utility company will charge more this hydro rate during the day, right? Because they have this off-peak this rate and then peak rate. They give you they charge you different this rate based on the time of the use. And this system is good, will save the hydro cost during the day when the sun comes up, and when the utility price is higher, you just use your own. And the other benefit would be like when the power grid is down during whatever the scenario, or this tropical storm or whatever happened, and nobody has the grid power, and you could still have the power from your solar array system and to power the emergency load. And if you size the battery bank big enough, you can also make sure this system will carry the load during off-peak hour as well at night. So this is the benefit and the application. This system looks identical to the system we just explained, 220 system, 50 Hertz system. However, this system is actually the 60 Hertz system in North America. Grid power is 120, 240. We call them a split phase system. It's 120 VAC or 240 if you connect L1 to neutral or L2 to neutral, that's 120. If you connect L1 and L2, that's 240. So this system is like called a split phase. Split phase, the inverter design is very difficult, complicated. Also, the automatic transfer switch, we don't find them available yet. Can have 3 lines goes in there, L1, L2, and then neutral. For this automatic transfer switch designed, very convenient with a proper DC setting there. They currently only available for 2-line connection. You can use it for 120 system, you can use it for 220 system, but it's only like a 1-line voltage, 1 neutral. Actually, the relay inside actually is powered by that line voltage. Without any power supply, it automatically fall back to the grid. So that is how the automatic transfer switch has been designed. No power, or the DC power is very lower, the system automatically fall back to the grid power. As long as the DC voltage raise above the setting mark, say 26.5, the relay will work, and then switch the load to the off-grid inverter here. So that off-grid inverter is make sure it's 120 VAC, 60 Hertz to match what you have. You notice that only 1 line being connected to it. L1 connect, L2 is not connected. Probably you can have the load connect to somewhere here for L1, L2, or L2 to neutral. But this portion here, we call them the AC load, mainly consumed during the day, or emergency power supply for the building. This load there can be powered by the PV system without even grid power supply. So this is the load we prefer to have them more this load consumption during the day. First is to save the power consumption cost. Second is that because this system will give you a lot of this DC current to power that inverter directly without even sacrificing the LFP battery charging cycle. So this is a system like 120 volt, 50 amps, can support like a 6 kilowatts, right? 5 kilowatt, 6 kilowatt system. So for 220 system, it can actually support like a 10 kilowatt system because the contact in the automatic transfer switch, they are rated 50 amps. So this is how much it can support, and then you know like how to size that solar array properly. What's the capacity you will be designing that for? You know maximum is a 5 kilowatts, 6 kilowatts, and then you want to size that battery bank according to the load consumption during the day and at night. We'll get into the calculation, capacity calculation later on, but this is the system you use them for split phase system. So this here we should say the 120 and then 240 split phase, but you only use them for a single phase, which is 120, because 120 inverter is more popular than the split phase inverter. This is the application, another application, pretty much identical to what we just explained. It could be 120 60 hertz system or 220 50 hertz system, single phase. But because you don't have that much AC load during the day, when you have maximum solar condition, you expect to have a lot of capacity coming into the system, but you don't have enough AC load during the day because it's not a grid-tied system. You cannot reject power to the grid. So it's a regular meter here only. You don't have the grid-tied approval, no grid-tied approval, and you have a lot of this DC current going into the system, and then you may not have that much AC load to spend the power. So what we suggest is that you could include a system with EV chargers. So the EV chargers could be just class 1 EV chargers to spend the load during the day. In other case of the scenario, you could use the DC power to power the PEM cell or AEM cell, proton exchange membranes, or anion exchange membranes to produce green hydrogen. The green hydrogen can be stored in the metal hydrate. This metal alloy inside the container can absorb a lot of green hydrogen, and you can build them in certain stages to change the temperature for each cylinder and to boost up the pressure, because when the pressure when it's room temperature 25 degrees, the pressure can be lower, and then if you cut down the green hydrogen this supply from the PEM cell, and this system can use the DC load, this power from the system to heat up the cylinder, and that cylinder pressure can be so high, boost up high, and it goes to the next stage with a check valve, so it isolates the high voltage there, and then open up the valve to have this process still going on. But we would want you to have the voltage sense, DC voltage, to kick in this PEM cell system to work at 27 volt mark, because that's about 90% of charge. We don't want the system voltage to still rising up, and then this PEM green hydrogen, this generator, can help you to produce the green hydrogen to spend the power during the day. So this is the split phase application, different from the one we just introduced. You only use L1 to N to neutral the single phase. You're not using 240 volt system, but you do have an option to use both phase, split phase, L1 and L2, to be able to make even class 2 this EV charger. Class 2 EV charger can charge 40 amps, 30 amps, so you can charge the EV in a few hours. You're going to have 240 times 30, 40, 50 amps, provided you have sufficient capacity from the inverter. This system, but you cannot use the automatic transfer switch, which is explained. You have a voltage DC direct setting. That's for 9 volts and the neutral, only for single phase. That is a cheaper one. You can also use it for up to 11 kilowatts if it's a 240 system, right? But we don't have this kind of product available yet. But if you build this system, you have to go for more expensive this transfer switch from different manufacturer. This contactor type transfer switch, they can have all this function built in there with a DC voltage sensing to transfer the load. They can also have this in-phase built in to make sure the motor appliances, the AC equipment can run without problem. Because if you don't have this in-phase transition, you don't have the delay transition, some of the compressor will not take suddenly power outage, suddenly power comes in, unless they have their own delay built in. As a matter of fact, some of the refrigerators, AC equipment, they already have that delay built in, because just in case the power outage and then power suddenly comes back, and to protect the compressor, because when the AC equipment run, the condenser of the AC equipment will build up high pressure. And then if the power suddenly off, the compressor stop, if they want to start right away, the compressor will hit a significant resistance because high pressure already built up in the system. But if the equipment built in some kind of protection, you would have no problem. You don't need that to have the delay transition if that's already built in there. But for some motor equipment, you do need to make sure it's in phase. This transition is also built in the transition switch, transfer switch. As you can see, this one is supported by two these identical inverters, DC to AC inverters. It could be 24 volt system for 3 kilowatts off-grid operation, or this 48 volt for 6 kilowatts, 24 for 3 kilowatts. This very popular, this off-grid solar inverter, and they have the communication cable connecting between these inverters. So they make sure this 9 phase 1, phase 2 is offsetted. If it's a split system, they're going to offset that for 180 degrees. So you're going to get 240 VAC when you connect L1 and L2. Another thing I would like to mention is that that single solar charge maximizing controller system with everything there, with LFP battery with the management system, MPPT solar charge controller, normally we make it to 120 amps for the solar charge maximizing controller, and 80 amps or 100 amps, the maximum you can make it is for MPPT solar charge controller. So the total system is 200 amps. If you have a 24 system, it's 5 kilowatt system. But if you have a bigger area and the load is big enough, you making them for class 2 charger, and then you can put another array into this to just add it up, and the system can be added up to 10 kilowatt system, 20 kilowatt system, but you gotta size the battery bank accordingly. Just to introduce this application, so you know that solar charge maximizing controller, it can be used for this split phase application, which is very popular in North America, you got 120, 240 split phase system for any residential house. Cottages depends on how big the property you have. You can build this solar array, install them on the roof, or install them rack mounted. Some of the commercial building also using split phase this supply, and you can put them on the roof. This flat roof can have quite a lot of this solar array built in, and you can make the EV charger, class 2 EV charger available for customer or for your employee, even business application. So this is an idea that can make it happen very easily to maximize the off-grid system or grid-tied system. So I'm sorry, it's not grid-tied system, it's a off-grid, but no hybrid system, but no grid tie. So this is the nature here we are talking about. But however, this is the transfer switch, relay type of transfer switch, not the automatic transfer switch. Directly you can buy it, but this has to be ordered from certain manufacturer. This is a very typical application in commercial building, three-phase. So we have three-phase, this 120-208 in white connection in many commercial setup. You could have 575, 600 volt, three-phase, 60 hertz coming to the building, and this is the typical commercial, this power supply to the building. You can have 575, 600 volt system, this appliances like a rooftop unit, and then you could have this step-down transformer to have a delta, which is 600 volt system, three-phase delta, and it goes to white connection 120 208 with a neutral white connection transformer, and then it will power a 208 system, white connection system, this load, including maybe rooftop unit or some other appliances. And then you can have a transfer switch built here, and that transfer switch can say used for building this power supply to some kind of appliances. You want them to be functioning even the grid has no power at all. So it's kind of backup. Or another scenario is you want to spend the energy from the PV system here. When the solar condition is good, available, PV system available, you want the load to be spent from the PV system. And then you have a transfer switch built in there. Of course, that transfer switch powering three-phase load, you have to make sure it's ordered properly. It's a DC voltage, control DC voltage. As we mentioned that, you have to have the system cut in at 26.5 volt, cut out at 25.5 or 0.6 volt. That's between the 20%, 80% mark, or even use up to 90% mark. So this is system like you order that transfer switch, make sure you have in-phase transition control, especially when you have some kind of three-phase motor. And of course, you can have EV charger built in the system. Commercial building, you have the whole system set up, and that solar array would be on the roof. This solar array can have up to 20 kilowatt solar array, but you have up to 6 of these inverters. A typical 6 of single-phase 120 VAC inverters is 2, join them together to take care of one phase. Second, join them together to make another phase. Another one, another 2 join them together to make a third phase. So that DC can be 24 system, can be 48 system, and they can produce off-grid this three-phase power to power the load. We use this system for a temple building, they have enough room on the roof for 20 kilowatts PV system, and then we have 6 of this inverter, off-grid inverter, connected through the communication cable to supply power to the 3-phase this system, including the rooftop unit, including some kind of the emergency power supply for the whole building, emergency lighting, in case you have a grid power down and that system still functioning. You can run some like exhaust fans, some kind of HVAC equipment. So just to maintain the basic function of the building, even run a boiler. Because the boiler doesn't draw that much power. So even the grid power is off, you can still maintain the basic function of this building. Of course, you can also have the PEM cell, this green hydrogen included in the system. If you have that much capacity and you are not using that much the AC load through the DC to AC or the inverters, you can use the AC, DC DC current directly to power this green hydrogen production, this setup in a commercial building. Of course, in the future, green hydrogen can be, well, now it's already, they make the equipment available with a green hydrogen. They kind of can be rejected into the natural gas line to mix up to 10% of the green hydrogen in the natural gas line to power the boiler. So it will help to fight the global warming if this system become popular like everywhere. And so this green hydrogen can also be used to produce actually the powers in case say winter time you don't have not much sun, but you put this green hydrogen store somewhere in the winter season, you take it out, and lots of these furnace actually run with the fuel cell, this system designed into it. They produce heat and they produce the electrical current to power the appliances. It's called a fuel cell. Also, of course, it can also run fuel cell these vehicles. Just lots of application. This is the system can harvest maximum power from the PV system. We say, okay, you can also produce this hydrogen, right? When you build a big plant, but that plant would normally have to be built nearby the hydro dam. Okay, that's green energy too, but it has to be close to the hydro dam. So you produce this power in AC format. But AC format, you have to use transformer to step it down to some kind of voltage, and then you still need AC to DC inverters to make that 100 amps of the current to run the PEM cell. So during that transition, during that transformation from AC, DC, DC, AC, you got lots of power loss, and then that hydrogen actually being stored in the facility far away from the customers who will be using that. Then you will have to reject that green hydrogen into the natural gas line. But the green hydrogen is like a very easy to leak. You cannot just put the transportation container and to ship the green hydrogen, because it's very high pressure and the transportation cost is huge. To reject into this natural gas line is a way, but you still have to increase the system pressure and may cause pressure loss. They only start testing this kind of system, but this on-site green hydrogen production has its benefit.